Good evening, ladies and gentlemen. Thank you very much for giving me voice. My name is Gawel from University University. I will today talk about using of uh, fat oils from algae or biofuels, different case, but fatty acid not taking out for the cooling as uh, as replacement for using now as freon or something like mineral oils that are used for cooling system. The cooling is on another topic that use much conventional for using conventional materials that will be needs to be replaced by something different. Therefore, besides, it's the very important case that we want to find how we can reorganize these fats if necessary or even possible for using this as cooling material. The cooling is very important in different countries, different everywhere, for keep preserving our food and preserving farmers. So we need to change to renewable way. My today talk is based on work published in transaction on dielectric and electrical insulation. In this month, the work was published by Professor Smolka and Dr. Michał Palacz in cooperation with uh, from the Silesian University of Technology, with cooperation of Argentinian Professor Rodriguez from Center of Computation Methods in Santa Fe. The work is showing using the mostly by showing theoretical position so as to check by calculation how or which point are necessary to look during experiment to obtain cooling oil by using uh, biodegradable oils from forest. Their case is using argas oil or, or lipids from industry, which will be separated or replaced by from waste, and therefore, of course, there is also some from silicons oil which can be used for to also cooling. The silicon oil would be the next waste from the computer science silicon and is used on some also some photovoltaics, which is majorly using silicon because are much cheaper, however less efficient than polymer photovoltaics, but is much cheaper, so are more useful. So ways for using is this silicon oil that can be also used. The thermal analysis was using the cooling system, and then the ratio to measure most and cut the geometry. That Stephen Session simulation was developed by electromagnetic model based of uh, on fluid electromagnetism and computational fluid dynamics by Fluent to check to find that the estimation of anisotropic thermal conductivities, the predicted flow of heat, and the model of stellar flow, airflow. This is also important to use this case to keep the low transition, low losses of energy. Basing on basing on this, and this basic on these three models built cooperation and was chosen as the most suitable and suitable idea for giving heat flux and temperature field observed, and this shows the reason. That by finite element method was based by partial differential equation showing nodes and field values for electric models using Maxwell's system. Therefore, these two models using also electromagnetic field and mathematical models using K-epsilon model for oil flow, so cascade model, and with Euler second version, and then using or four-stage system, and these discrete ordinates. These results submodels shows windings and thermal properties of oil should be this is the synthetic oil. The density is much higher than in case of mineral oil. Therefore, we need to obtain some properties like mostly. So this would be high to use that mostly would be much high amounts of this oil than in case of traditional cooling cooling methods, and thermal conductivity is much slower. Therefore, however, the technical thermal conductivity will be density and thermal conductivity higher. Therefore, would be some keeping this heat by bigger load. So we have to design that density is much higher, but the thermal conductivity is better. Similarly to and this show a similarly to better dynamic viscosity. So the viscosity, especially in temperature higher between 40 and 0, after 60 degrees is better. Therefore, we should be have to flow, and one of ideas is this biobutanol adding and some nanoparticles to this oil to remove this viscosity. The heat capacity is very interesting. The advantages of this oil are high heat specific capacity and the thermal conductivity. We need to find a way to remove this high dynamic viscosity, which will be clogging our pipes, cooling pipes. And then we need to find methods, and this showing the temperatures, the model which find to be needed to be checked during uh, uh, this find. So the temperature that we need to be checking, some corner temperature by this modeling, is minus 10, 20, and 30. And there was using the two models, these two models, and electromagnetic model losses estimation based on finite element models, and mm, and computer fluid dynamics submodel estimation of effective anisotropic thermal conductivities of windings. The computer fluid model components of the transformer and oil flow for the heat dissipation from the transformer via transformer oil to tank. And this computer fluid dynamic model flow around the transformer and heat dissipation feed transformer casing into the environment. Therefore, this showing the differences what to make. We have high viscosity and high density of such oil, fatty oil basing of natural ester oil. But we have higher conductivity and higher heat capacity than conventional oil. So we have these four variables to to model, and by used experiments to review to design the most efficient cooling oil. But this is important to find solution to uh, design a cooling system that can be based on renewable and sustainable cooling carriers and materials, fluid. So thank you very much for listening to me.